जैन सिंह आप सबका आज के इस विशेष वेबिनार सत्र में स्वागत करता हूं। The title of today's webinar is Introduction to System Engineering, and we are excited to have such an enthusiastic group of participants who have joined us today. I am also pleased to share that this webinar is a part of our new initiative by Indian Aviation Academy to organize webinars on the first Wednesday of each month. The aim of these webinars is to familiarize the employees of Airports Authority of India with the new courses and training programs that are being introduced at Indian Aviation Academy. We believe that this initiative will help to bridge the knowledge gaps and also to keep everyone updated on the latest developments in the aviation industry and also on the front of the training programs that are being provided by Indian Aviation Academy. So the key objectives of the today's sessions are: the first one is to introduce the core principles of system engineering and highlight their importance in the civil aviation. The second objective of the today's session is to explore how system engineering can be applied to aviation infrastructure development, ensuring projects are being delivered efficiently and effectively. Now let me introduce to the speaker of today's session. It is my privilege to introduce our esteemed speaker for today's session, Mr. B. Senthilvel, sir, the General Manager Training at Indian Aviation Academy. Sir, Senthilvel sir is a highly respected professional in aviation industry with expertise, extensive experience and expertise in training and development. His expertise in system engineering and project management combined with his deep understanding of aviation infrastructure makes him the ideal person to lead this session. We are fortunate to have him with us today to share his knowledge and insights. Now, without further ado, I would like to hand over the session to Sir Senthilvel, sir. Sir, the floor is yours.
Thank you, Mayank. Good morning to all of you. We have given a very short notice for this webinar because Friday myself and Mayank we were discussing that we should start the webinar on system engineering on Monday itself. So that's why we came out with this the first topic. So we would like to apologize for the very short notice. Further webinars we will give in a much advanced notice. Now, without wasting any more time, let us jump into the topic: Introduction to System Engineering. So before we proceed, I would like to know how many of you have a basic understanding of system engineering. This is not a, you need not to give a very detailed response. You can just say yes or no in the chat box so that we will understand how many of you have got basic understanding of system engineering. So you can type yes if you know, otherwise you type no if you do not know. Irrespective of anything, there is no issue. We are here to gather the basic understanding of system engineering through this session. Now next, I would like to ask one more question. How many of you have practical experience or wider understanding of system engineering? Again, you can say yes or no in the chat box. Based on that, we will proceed further. Now, you have given you have been asked two questions and you have given the response. But what is actual truth? All of us are practicing system engineering. With the present safety management system framework, we are all following the system engineering concepts. But yes, sometimes we are not scientifically taught or we have scientifically acquired the knowledge and skills of system engineering. So in this short webinar, we would like to cover, I would like to introduce the system approach and system engineering and key principles and concepts behind the system engineering. What is system approach activities? Then we will see what are these system engineers application in our real world examples. Also, I would like to highlight shortly about our upcoming webinars and other new initiatives we initiate from IAA, where you being a major stakeholder, we need your inputs. Further, in this slide, when I will share after the webinar, I have added some slides for your self-learning for verification and validation and deployment, use and sustainment. Now let us start our first module. Introduction to system approach. Before we start about system approach, we need to understand what is system. Systems are of a combination of interacting elements organized to achieve one or more stated purposes. The elements can be people, it can holistic integrative approach for identifying and understanding complex. Okay? No, yeah. So not muted. No, he is muted. So Mayank, you have to unmute my audio.
So now audio is coming.
Okay. So system approach, the holistic and integrative approach. What is the holistic integrative approach for what we have to do for identifying and understanding complex problem and opportunities? You can easily visualize our ATM automation system or airport baggage handling system or safe security system. These are all very complex system. So we need to consider the entire system, including its elements, interaction, and the environment on which the system is going to perform. Once we have certain fundamental approach like this, we will have a lot of benefits that we will see in this presentation. Then what is system engineering? It is not a engineering subject. It is an interdisciplinary field that focuses on designing, integrating, and managing complex systems. So we need not to think that this is pertaining to so-and-so wing or particular engineering graduates. It's not like that. We all are, as I told, we all are involved in this system engineering. When we focus in this system approach, we will be able to use the system's principles and concepts along with scientific, technological, and management methods. So could you list some of the systems you work with? So anyway, we are going to discuss a lot of things. But before that, I would like to know, any one of you can share the system in which you are working. You can take a minute and you can share your answers in the chat box. So there are so many systems. It is not one. I have just listed a few systems for your reference, but I'm not going to list or read everything. One or other system you are already familiar and you are working with. Okay. Now let us proceed to the next point. Why there is a need for system approach and why there is a need for system engineering concept? Why we have brought a new training course on the system engineering and project management? The importance of this, when we see a holistic approach, all elements of a problems are considered. So that when the problem is defined properly, holistically, naturally you will arrive at a comprehensive and effective solutions. The next point is, when you see the end-to-end, the entire problem, then invariably you will involve all the stakeholders into the consideration. Otherwise, what will happen? The last minute when the project is going to be commissioned, you will find that some of the stakeholders' views are missing or their needs are not materialized. So what is the advantage of this system engineering is, this ultimately to lead to higher satisfaction and better outcomes. Then interdisciplinary collaboration. Like I told, it is not pertaining to some particular scientific, means engineering graduates or somebody, or the particular subject matter experts. It's the interdisciplinary collaboration is required. Then only we will bring all relevant perspectives can be included in the problem defining stage itself, so that the solving of the problem will be scientific. Then life cycle management, right from the conceptual stage to the disposal of the system, we need to ensure that it is the system is put into use in the right manner for which it is designed, and also it is maintained in a sustainable manner till the time we need a service. Also, we should be able to dispose it when we don't need those system in anymore. Then risk management. By considering the entire system and its environment, potential risk can be identified and mitigated earlier. Say, suppose you are designing some airport baggage handling system. So, a particular airport, the particular topography, there may be different potential risk can be coming. So, when the initial stage itself you identify this, you can mitigate in the design process itself so that you will get a very good results in the end. Then efficiency and effectiveness. Integrating various discipline and perspective leads to more efficient process and effective solution it will give. So, in a nutshell, what is the importance of considering system engineering is organizations can develop and manage complex systems more effectively. See, I could recollect my initial exposure in automation project at Chennai Upper Airspace Organization, where we were integrating so many radars, so many sensors. Though it's all technical system, but invariably you have to network human being also. Otherwise, this networking cannot be done. So this once you see the end-to-end entire system in a complex project also, you can effectively complete in time and later it can work as per your need. So now let us move to holistic view. We talked about holistic view. What is holistic view? The whole system consideration. This point we have already discussed. So you will understand the entire system and their interactions and dependencies in different system component level you will see. And you will also see how they are interacting with each other and how, including users and also the environment on which these components are going to interact. And emergent properties also we will understand. What is emergent properties? Individually, a system component may not clearly tell you a behavior that will give or that result that will come out of a system, part of a system. So this individual component you should not see only as a individual property or characteristics, but you should be able to visualize emergent properties, how it will come when the so many components are interacting. For example, human being. Human being is the most complicated or complex element. So once you involve the human element into a complex system, even a normal system becomes complex when we involve human being. So you should see how what kind of emergent properties will. This is only called holistic view. It is not that you are going to do all this brainstorming or anything in a closed room. You think that you are subject matter expert. No, we have to involve each and every stakeholders into the interaction. Now we will see the life cycle of the system. See, you can correlate if you those who are well versed with the SMS and those who are doing scars analysis, you can visualize how I told in the beginning. With the present SMS framework, we all are following the system engineering principle, but however, we need to have little bit scientifically organized knowledge. So the life cycle of the system, first it starts with the conceptualization. So here only you are identifying a problem. You are defining a problem. Once you identify a problem, you also will go for an opportunity. We'll discuss this little bit more detail and engaging stakeholders to gather requirement and constraints and developing concepts and feasibility studies. This is the first stage, that is a conceptualization stage. The next only are going to design and develop. You may wonder, you may ask, we are mostly buying systems from outside. Then why should we know system engineering? We are not designing, we are not developing. No, we need not to be expert certified system engineering person or project management person. But at the same time, we should know that at least the basic flow of the entire system engineering project management. So that these high value projects, when we do, we will not lose any ends. Though you are outsourcing this design and development, again it comes to your hand only when you do the verification, validation, deployment and use. So it's better you should understand the entire chain of the system engineering. So the design and development, you can also decide whether we will do internally or we will outsource this design like that. All those things are decided on this design and development stage, and what are the components, how we are going to integrate. All these things we will discuss in this. We will deliberate in the design and development stage of the system. Then it comes to the implementation. When you implement, first individual component or a small part of the system you are energizing and putting into the test and checking, then integrating one by one all the system components. Then finally you are going to come to a final verification validation that will give you the what exactly you decided that system should meet. The stakeholders meeting you decided, you defined the user requirements, that finally you are going to assess what exactly the system wanted to meet and what it meets. So you have to do a lot of test and evaluation to prove the system effectiveness. Then deployment and transition. So you have already some system, you will have to transition to the new system. Just like that, we cannot switch off and switch on the new system. Let it be anything. It's a new runway lighting system, or new security system, or ATM automation system. We have to do a development of, before putting into operational use, we have certain transition plan. So how we see compatible with the existing system, how we will train the new users so that they will be in a position to know about the new system, everything. Then operation and maintenance. So once we assured that all the verification validation is done and everything integrated, it meets the requirement, you can put it to the use. And naturally, once you put it to the use, you have to maintain for the optimum performance. Then finally, decommissioning is the last stage of the life cycle of any system. So in this, so far, whatever we discussed, you might be understanding most of the system engineering concepts are already you are aware, but we need to ask ourselves how sincerely or scientifically we do this entire holistic approach when we do our work.